Okay, now we're going to talk about section 2, and that is the idea of mapping over image collections in Earth Engine. And so I start by saying that the word map comes up all the time. It's encountered again and again in cloud-based remote sensing, in Earth Engine in particular. And it's really useful to be able to distinguish those. It's actually really important to be able to distinguish those. So I identify 3 places where the word map comes up. We say the map, and we say that just sort of in a friendly way, in a non-technical way. And what that is referring to is this formal part of the interface referred to as the map panel. If you use the interface tools, which we'll learn about later in the book, this can maybe also be called the main map, M-A-I-N-M-A-P. But for now, for us, it's the map panel. So that's like an object. In the book, every place that we refer to the map panel, I think, we have put it in bold so that it's clear. The second way of using it is as an object that things can be done to it. When you do that, when you type this type of phrase in code, it turns purple over here in the editor. One of the people who worked on the book worked for several weeks to try to figure out how to get that exact color of purple into our book, and he is a genius and was able to figure it out. So that was really neat. So everywhere it says map.addLayer, that is shown in purple because you will see it in purple over in the editor. So things like map.addLayer and map.setCenter, you notice that the letter M is capitalized, and we capitalize it in every case there, and it's put in purple. What we're talking about here is the idea of map as a verb. So in the other cases, these are nouns. The map panel, I guess that's maybe an adjective, that's a noun, but this is a noun and that's a noun. What I'm referring to is this as a verb of doing an action of mapping. And that is, I think in R, if any of you are familiar with R, the similar word is apply. So you say, I have a function, I have a set of things, I want to do this function again and again to these things. In Earth Engine and in JavaScript also, I think, .map is the phrase for how to get something to run repeatedly on a set of things. So here again, we follow the way that the interface looks. And you'll notice in these cases, .map, all these letters are lowercase. There is a period in front of it, and it's purple. And so that is what it looks like. So what we do in this section is we take an existing function that we wrote in that other thing. We have it in the code here, and we run it again and again. And so we could have picked any function. The one that we picked uses, calculates the enhanced vegetation index. And so what it does is basically to calculate a ratio of some bands in an image. And so we have a function that does that, and we want to run that again and again for the entire image collection. Now, you could think back to our example of the milk. We could compute this vegetation index mapping that was analogous to calling a store and asking them about milk. We could compute the enhanced vegetation index for all 1,862,000 images and then figure out which ones we care about. Or we could filter to figure out which ones we care about and then run this operation just on those images. And that's why this is a real concrete way of why the order matters. Because it's better to do it just on the images, on the 83 images that we care about, instead of doing it on 1 million images and then throwing away all of them except for 83 of the results. So here in the code checkpoint F4.0b, you'll see this where we take that efficiently filtered set. This is the set of images. It's an image collection that has been filtered. And we map the function called make Landsat 5 EVI. We do that, and then we're going to print out the size. And it should give back the same number of images, but give different stuff. Then we're going to add it to the layer, and we'll add it to the map panel in bold, and then we'll see it. So I'll go back to my scripts here and go to F4.0b. And there it is, F4.0b. You can see that change. And if I remember right, that looks just like F4.0a. I'll go back to F4.0a for just a moment. That looks exactly the same, but now we've added, this ends at line 48, we've added on some lines down below. So our code checkers spent a lot of time making this stuff all look the same from piece to piece. And so here's that function. I just copied it from the earlier chapter, F3.1, I think it said it was, and it's a function called make Landsat 5 EVI. So down here, we define the function, and then we say, okay, I have this set. It's a filtered set. I want to, I've done filtering. Now I want to do mapping, map. And so please execute this command, this function on every one of them. And we can do that. And so then we'll hit print and see what it does. It should look just the same. And so here's the end of our efficient filtering. You remember in F40A, there was nothing drawn to the screen, but now we'll see in a second what that is. Then we calculate the dot map, and that should also give the same number of images. Now it's worth thinking about that there are 83 images in a pile here. How can we tell? Oh, it's still calculating the all images ever, but there's 83 of them in a pile. I should be able to use the inspector and click in one of the spots, and it will say, yes, you have a series of 83 images, and it shows us just one of them for us to be able to understand how it works or what's happening. I can click on this little list image, and that gives us all of that. And we can see the 0.932 was the last one, the most recent one. So if you ever find yourself drawing an image collection, and you say, what is it that's being drawn? It turns out it's the last value of, in every pixel, it gets whatever the last thing, latest, most recent thing was, even if it's kind of bad looking down here. If we go down here, we can see that the last image over here, these two probably come from different final images. And when we look up close, it's not a very clean looking image. And again, this isn't reduced. We haven't summarized these 83 values. This is just one picture, the top, sort of, if you could imagine a pile of maps on top of each other from the most long time ago on the bottom up to the top. This is just showing whatever's on the top. So if I click over here, I don't have as many. I have only 34 images in this pixel. In the other place where I clicked, I happen to have 83 in that location. So really, I got kind of lucky by clicking over here that there were 80. I think that would have confused me at first if I clicked somewhere else and I saw a number below 80. But the idea here is that I think every pixel here has less than or equal to 80 in its stack, and you can click around and try to explore that if you want to. So that is the idea of doing the map. I'll just show you again. Where did we get that? That is down here in line 75 of F40B. And we say, I have a nice filtered collection, and I want to map this function over all of the items in that collection. And so there we can see it does verify that it has the right number of items, and it draws them onto the screen. And so that is the end of section 2 within the book.